What causes creep deformation in metal components? Imagine a metal part in a machine that seems to stretch or change shape slowly over time, even without any sudden force. That slow change is called creep deformation. It often happens in parts exposed to high temperatures and constant stress, like engine turbines or power plant boilers. When metals are heated above about 40% to 50% of their melting temperature measured in Kelvin, atoms inside the metal become more mobile. This increased atomic movement allows atoms to diffuse or move around more easily. As atoms move, they help dislocations. These are tiny defects in the crystal structure, glide or climb, which causes the metal to deform gradually. Dislocation movement is a big part of how metals bend or stretch under stress. When temperature rises, atoms can diffuse along grain boundaries or through the crystal lattice, making it easier for dislocations to move. This process is called diffusion creep. It is especially active at lower stresses and higher temperatures, and it causes the metal to deform like a slow, viscous fluid. There are two main ways creep happens. The first is dislocation creep, where dislocations glide along slip planes or climb perpendicular to these planes, both facilitated by atomic diffusion. The second is diffusion creep itself, where atoms move through the metal's structure or along grain boundaries, causing grains to slide past each other. This sliding can lead to deformation and sometimes even cracks. The size of the grains in the metal matters a lot. Fine grains have more grain boundary area, which can speed up creep because grain boundaries are easier paths for atomic diffusion. Coarser grains tend to slow down creep because there are fewer grain boundaries. Creep usually happens in 3 stages. First is primary creep, where the rate of deformation drops quickly as the material adjusts. Then secondary creep, where the deformation rate stays steady for a while. Finally, tertiary creep, where the deformation accelerates rapidly until the material fails or cracks. In real-world applications, creep can cause metal parts to stretch, warp, or crack over time. This is why engineers pay close attention to the type of metal used, its grain size, and the operating temperature. Proper material choice and design can help prevent failures in high-temperature environments like turbines, engines, or boilers. Understanding what causes creep helps us build safer, longer-lasting machines and components.